everybody. I'm Faith from Elastic's Community Programs team, and welcome to our first virtual Elastic DC meetup. If you couldn't tell already from the link mix-up, this is the first time we're having one virtually. Elastic is putting on weekly virtual meetups that you can access through our NASA virtual user group on community.elastic.co that I will send a link to in the chat. Today's presentation on search and analytics and examining open data with a search index is from Richard M., a solutions architect on Elastic's federal team. If you'd like to present on one of these in the future, we'd love to have you, so just please let me know in the chat and we can set that up. Without further ado, here's Richard. Thank you.
Thanks, Faith. I appreciate everybody joining today, especially since Elastic might not be the most important thing and top of mind. So we really do appreciate y'all joining to learn about what we've got going on. I am going to give you a brief update on some other things that we're doing too that you may have missed in the past week since people have been in and out of the office for the past 14 days and such. But let's go ahead and get started. So if you're not familiar with Elastic already, I do want to mention and point out that we are a fairly large tech company. We are very much in almost a startup mode. However, we are in the post-startup phase. So we're growing our business and our R&D staff to facilitate that. And we are global, in which we're actually established in 40 plus countries with developers pretty much around the world, supporting and providing expertise and code to our platform on a day-to-day basis and developing our roadmap. Oh, why is not? There we go. To start off, I do want to mention that Elastic is a search company. So if you are not familiar with the capabilities that we provided from a historical perspective, it's worth mentioning that we are built on a platform and foundation of being able to search for data. And when it comes down to business analytics, enterprise search, you want to have that Google-like experience where your results and answers are near instantaneous. And with that foundation in place, we can apply different types of analytics and use cases on top of this data platform. So if you think about how you get matched with another user of an app, such as Uber, where you have questions regarding geospatial, location, temporal, right? Because you need to know where you are as well as other people are at the same time, and being able to match that up. It's a pretty expensive problem to solve with your traditional relational database systems, which tend to have scalability issues, performance issues, as well as just overall precision issues. But if you think about this particular use case, you're really searching in multiple different dimensions, and how do we service something like that? And then last but not least, especially in today's climate in the last several weeks, if you're looking for a place to eat that has carry out and delivery, right? And open when you're getting that hunger for a little bit of Thai food or something, you might use an app like Yelp to help you find that information quickly and easily across a large scale of available and open restaurants in the area. So whether you're searching for jobs, or latest grocery and delivery, right? So one of our customers, Instacart, uses us as a platform to help deliver their shopping and shopping cart capabilities for end users for delivery. It's all built on Elastic on the back end to help facilitate that search and retrieval and seeking that information quickly as possible. So we thrive on being able to promote ourselves as the platform to provide speed of not just data searches, but the availability of data from generation from source to availability for searching and analytics to scale across wide data sets, and then making sure you have that proper relevance to what you're looking for with the data. Elastic is a search company, and we're going to focus on fast results and making sure that our platform can react to your needs from a data analytics perspective. So we focus in three main verticals. I know that today's discussion is primarily around business analytics, which doesn't sound like search, doesn't sound like observe, and doesn't sound like protect. But it does fall under what we would consider our search side. So think about what we do as a company. we provide Elastic Enterprise Search as a vertical solution. And then we also provide observability for IT operations and serviceability, and then Elastic Security to ensure your enterprise platform, your enterprise data centers and devices. So with Elastic Enterprise Search, we have workplace search, app search, and site search. And these components essentially layer on to make it easier for developers to adapt to our data store and leverage its sort of NoSQL capabilities to build applications for their users and their requirements, and allows you to easily implement these capabilities without necessarily getting caught up in the nuances of the back end of Elasticsearch and all the minutia of the features around boosting and relevance tuning and things like that. Elastic Enterprise Search solutions like App Search and Workplace Search allow you to control a lot of that and gain visibility on the analytics that are being provided around how your app is interacting with the data store. But from a business analytics perspective, the main backend platform leveraging Kibana will be able to use and ingest data from enterprise data sources to provide that sort of visibility from an enterprise perspective. So Instacart, they, as I mentioned, is a company using Elasticsearch, primarily used this as a search engine, but it's grown into much more in terms of use cases. So the ability for our platform to be used in a wide variety of use cases is really what brings a lot of our customers to us and stay with us, because of the fact that they don't need to invest in multiple different products and multiple different technologies in order to get the analytics and engine answers that they need. Elastic Observability. So this, if you think about where we've been most popular lately, it has to do with logs and metrics and being able to monitor and keep an eye on your enterprise infrastructure. So essentially being able to collect all the server logs, the metrics health, and the telemetry information from all of those endpoints and devices, and then coupling that with APM and traces of applications that you have deployed in your environment allows customers to really get into a uniform view of their entire enterprise IT operations. And what this is really going to aim to do is allow you to collect all that data into a single platform, apply multiple lenses on it, whether you want to just search within the logs itself, whether you want to view traces in your applications, or whether you want to just look at the health metrics within your infrastructure, whether you're viewing them as individual hosts or pods, etc. We're going to provide you that in a single stack. And what does that provide from goals and objectives perspective? It's going to allow you to remediate issues much faster and quicker when you have all the information available in a scalable and efficient and speedy platform like Elastic. And lastly is the Elastic Security Stack, where we have coupled our strength in endpoint security and SIEM that allows us to really provide the global detection, prevention, and response capabilities that enterprises need today in order to work in a security context and keep their environments safe from the adversary. So for us, we definitely think that security should be done in the open, where sharing of information and techniques and tactics are well known across different enterprises. So for us, making sure that our technology stack is available for anyone to use is key for us. We also invested heavily into something called the Elastic Common Schema, which normalizes data sets across all sort of IT properties in your environment. The great thing about this is that we're capturing all the relevant fields that we feel are necessary to provide the security analytics engines that we have the right amount of data, so that way we can alleviate the typical alert fatigue and the typical slow response from a threat investigation perspective a lot of legacy security analytics products have. So for us, we want to take this into the next generation by coupling things like machine learning, as well as our newest feature here, which is the detection engine, allowing you to essentially detect your threats on your environment quickly and remediate that as quickly as possible by leveraging endpoint security and a global detection response system like Elastic SIEM. Today, however, we're really focused on a specific sort of user scenario that I see a lot of folks wondering about and asking about. And it's really, hey, we've got so many different data sources that are really geared towards less of a sort of back office infrastructure monitoring use case, but tons of database information, transactional database information based upon what we do as a mission or what we do as an agency. Perhaps we also have a relevant social media presence as an agency, and we want to harvest some of that data to help us understand what is our sentiment like. Oftentimes, agencies and the federal government use web APIs to source data for a variety of use cases, like OpenData, .gov, and a variety of other places. And then lastly, there are some SaaS services that they might be using, whether it's HR related like Workday, NetSuite, or ServiceNow. Basically, SaaS solutions that help them operate their agency and perform the duties that they need to do. How do you get that data, refine it, and make it usable in Elasticsearch and apply all the necessary controls for that data, making sure that the right people have the right access? And then how do I apply advanced analytics capabilities to that with things like machine learning? So today we're going to focus primarily on that and using Elastic. Typically, maybe you've not thought of it this way, right? Everyone hears Elk Stack for Elastic and Logstash and Kibana, but we do see many customers leveraging it in this capacity as well. From a reference architecture perspective, it may not seem very different from what you're used to from a logging or other use case perspective, but effectively we have these components here that can source data from things like billing and back-end systems, core agency mission systems, SaaS services like Salesforce.com, maybe marketing databases like Marketo, and even your traditional data warehouse database. So let's get that data efficiently ingested into Elasticsearch, and we'll apply those schemas that make relevance for this information and make it available for querying and analytics. And then from there, we'll leverage all the capabilities that are available in Kibana. So let's create these visualizations and let me sort of test out my hypotheses. What are important measures for me to look at consistently? And take those visualizations and put them into a dashboard so that way we have something that we can produce and report on a periodic basis. These dashboards react great. Many render in a few seconds or less. If you think about traditional BI tools, oftentimes they're connected to, let's say, a data warehouse. Unless they're in specialized data marts, your response times can take minutes to hours to churn back. You shouldn't expect anything like that with Elasticsearch. You can apply some of our advanced capabilities like machine learning, where we can detect anomalies in your data sets. You can just explore, look at the data, see how it distributes across time, look at patterns, look for visual cues so that way you know what to look for from an agency perspective moving forward. So some of the questions you might think about here, if you're a growth-oriented company or you're a growth-oriented agency, you might want to take a look at trial funnels. Who's testing, who's visiting your websites, and going further down into your evaluation track that you've set up. Or perhaps what are some of the citizen usage patterns that you're looking for as far as your services go? Is the IRS's website as optimal as it could be, or are you seeing a lot of drop-offs? So this type of solution allows you to sort of detect that and analyze that information so you can improve your forward-facing data systems. You're having retention and churn. What does my infrastructure look like? How am I using it? And as we move to the cloud, how much of that is being used efficiently, and are we being cost effective? These are just some of the things that many of our customers try to answer. And we can leverage things like machine learning and alerting. So as some of these data streams continually update the system, they'll help you forecast things. Do we need to increase capacity, reduce capacity? Are things split out regionally? If so, how do I ensure that funding goes to the right places? What can help me predict some of that information? And proactively identify some of the anomalous behavior. So the need for business analytics is truly there, especially in today's world where everything's being measured and people want to use data to drive their decisions versus gut feelings. A lot of folks try to do this with traditional data warehouses. A lot of folks try to do this with a lot of other tools that are available in the market today. But why Elastic? Elastic is going to provide the answers in a much more coherent as well as expeditious way that today's business world and mission world doesn't necessarily have. And if they do have it, they may be doing it in a much more cost inefficient way, where Elastic allows you to do that very efficiently from a cost perspective and project future costs as you need to as well. So in terms of analysis and business use cases, we're going to analyze, explore data, share, and be notified. So in these areas, in a typical data analysis pipeline, you're going to leverage some features that we have inside Kibana. You use scripted fields, control visualizations, right? So you can be able to use sliders to explore the data in your dashboard. So I have some of this built out today. You can explore the information with Lens, which is a semi-new capability that we've introduced that allows you to drag and drop fields into a canvas, or I should say, a dashboard-like feature and view the data in multiple different lenses, pun intended. And then share this information. If you need to share the dashboard as a report or export simply the data elements that represented it, you can export it as a CSV file. So just to summarize on the slide deck perspective, I do want to emphasize and say that at Elastic, we're providing 3 solution areas with 1 stack, right? So the Elastic Stack itself built upon the Elasticsearch core storage and analytics engine with beats and Logstash that are feeding the data into the system, and Kibana providing the visual user experience for Elastic Observability, security, and business analytics. Skip this. I do want to mention that Elastic has been available as a SaaS PaaS offering in the Elastic Cloud public cloud domain. Today, I want to take a moment to announce that we are officially designated the in-process designation from GSA for the FedRAMP process. So what we've done is we've taken the Elastic Cloud that many customers know and love and deployed it into the AWS GovCloud region. Just recently, last week, we announced that this deployment is available for usage and consumption for anyone doing business or providing services to federal government as a beta. And we anticipate it to be fully available in due time. So I do want to encourage folks to understand that as an offering, we now have 2 ways to consume Elastic as a cloud service. One is through our standard public cloud, which is secure, well-known, and already managing over 17,000 clusters in a single multi-tenant environment that allows you to choose between AWS regions, I should say AWS commercial regions, GCP commercial regions, and Azure Cloud commercial regions. The difference with GovCloud and our FedRAMP installation is that it is specifically geared towards providing the deployment and management inside of Amazon's GovCloud US East region. From the ground up, it was built to meet the demands and needs and compliance and regulations of the federal government as we went through the FedRAMP process, providing a system security plan well over 400 pages that ensures that our operations and our procedures meet the needs for a moderate level FedRAMP. This allows you to centrally manage your Elastic deployments in the cloud as a multi-cluster use case. So as you have user groups that have different needs, you can size them differently, you can scale them differently, and you can manage many different versions of Elastic in that environment. If you're a little bit more hands-on, I do want to mention that we do have Elastic Cloud on Kubernetes as an operator. It's an official operator that takes advantage of a Kubernetes-based infrastructure environment that you might be leveraging. And today we're supporting Red Hat's OpenShift, Amazon's EKS, Azure's flavor, as well as Google's flavor of Kubernetes. And we do have a variety of different options in which you can leverage our capabilities. We do have the traditional, well-known open source versions, as well as our basic license. But then there are some paid and proprietary capabilities that we provide, primarily around things like machine learning, the alerting capabilities I mentioned, and some of the advanced capabilities with endpoint security, as well as things like workplace search and app search. All of this is available on the Elastic Cloud. So as you consume there, based on the size and needs that you have for the resources you need to consume for the type of analysis and data you ingest, it's all available in the Elastic Cloud that you can pay as you go. Thank you for this part of the presentation. Now I'm going to flip over and actually move into the demo, but I'll take a pause real quick to coordinate with Faith whether or not there's any questions so far.
No questions yet.
Awesome. I really wish I could get this full screen, but let's try it this way. Okay, so first and foremost, I do want to mention to everyone that the Elastic Cloud access with our FedRAMP GovCloud region in beta is available by request only as of now. So you do have to go to this site, this URL, to make a request to gain access. Anyone who gets access will be given 14-day free trial of a very small instance. I love the cloud offering that we have because it's easy for me to spin up my Elastic cluster without dealing with all the nuts and bolts underneath to make sure I have something provisioned, doing the downloads, making sure I unzip things right, and making sure I have all the configuration, the host names, and all the, so a number of things that need to go on. But with the cloud, I have a fully secured end-to-end capability that already has TLS enabled, it already has user authentication enabled, and allows me to get started in about 5 minutes. So I do encourage you, if you just even want to poke around, take advantage of the 14-day free trial and request access to our GovCloud capabilities. I'm going to walk you through real quick just this particular region in our cloud. Let's log in here. So one thing that you'll see that's different is that, again, this is its own instance of our management plane inside the AWS GovCloud. So if you see the URL here, you'll see that's different. We have console.usgoveast1 aws.elastic-cloud.com. It's going to be different than our public cloud, which is cloud.elastic.co. Once I log in, I'm presented with a very similar screen of what we have offered in our current PaaS environment. The only difference here is I'm not going to walk through every step of this. I'm going to create a deployment. The one difference here is that we're going to designate this today as beta. We have any sort of specific US-based warnings or US federal system warnings and things like that. And you get one region to choose from, and it's the US East GovCloud region. Now, as we see utilization rise, we may consider adding things like US West GovCloud and other US GovCloud regions that might come online here based on demand and capabilities that are required with our federal agencies. But it's for today, for now, in the beta, we have the US GovCloud Northern Virginia available. From here, we make it easy to select the type of cluster and EC2 type deployments that are going to back our environment by choosing things like the IO optimize, the compute optimize. So these cluster templates allow us to really make sort of the safe decisions around how we want our clusters to be deployed. The beauty of all this is we also provide your pricing. So this is the free option here. It will be 66 cents per hour afterward. And go ahead and create a deployment. So I encourage everyone, again, sign up for the beta. Please try it. 14 days, and you can just play with your own cluster and data afterwards. But today, I'm already loaded some data into a Kibana instance here. This Kibana instance, again, is in the cloud, but let's see. but it's been preloaded with some information here. This information actually is downloaded from OpenData site for FEMA, in which they had some information on flood insurance claims. I loaded this up probably about a month ago, and you'll see here that we have about almost close to 2 million records that have been collected during this time frame. So primarily centered around 1970s up until even 2019. So it's fairly recent, fairly up-to-date information based on some of the flood information that we have available through FEMA. But how I got this data in was pretty easy. So we mentioned all the sort of automated or IT-centric ways of interacting with the data, but a feature that's less known or may not be as well known is under machine learning, we have what's called, get out of there, what's called the data visualizer. So the data visualizer, if I click on that, prompts me with an ability to import data. So I can upload files, and it kind of gives me a few rules I need to follow here. So we need some sort of delimited text file, a CSV or TSV, or an NDJSON file, or some other common log formats that might be available. And we do have a small size restriction. I do know that this will be lifted to be a little bit higher in the future. But today, the reason why it's so high is that all the processing happens in your browser before it gets sent and loaded. But for demonstration purposes, go to data, go here, go in here. So if I just click this CSV, click open, what it does is analyzes this data for me. So there's some header field information that's already supplied as part of the CSV file. I have the ability to override some of these settings. So if I know that I want to use a different type of date format here for my timestamps, how many lines do I want to sample to make sure it has the right statistics around things? What are my delimiters and things like that? So this helps kind of do sort of the schema matching for me, right? So what fields are available. I can also customize my field names if I don't like what's available in the header, but for this purpose, we're just going to close that out. What's great here is also we get all the information around each field and some of the semantics around it. So we get statistics if it's a text field, right? So we have things like what are distinct values, as of date. They're number fields. It's going to tell us, all right, what are the top values? It's going to give me all the statistics around the values within that field, which is very helpful if I'm just exploring data and just need to visualize this data. When I'm done, I can just hit import here. And what ends up happening is that it'll actually create a new index inside of Elasticsearch for me to start to explore. And we can have it be part of an existing index pattern, or it can be a net new index pattern. So let me go back to out of the data visualizer. Since I've already gone through those steps with importing my data, the 2 million record from FEMA, once it's been imported, I get this view of things. So we're in the Discover app. So if we look here, it's Discover, Visualize, Dashboard. We're going to mainly stay in this area here, but we have so many other features that you can take advantage of and explore with our cloud trial. But within the Discover app, right, it's really just a way for me to sort of look at my data and just start to run queries with it. So in this case, I have a date histogram that kind of gives me the spread of all my data. You see here, there's clear indicators that, hey, there's some spikes in claims in 2005, 2012, 2017, and there's no trick here. This is all going to coincide with recent historical events of flooding that have been probably in the news and y'all probably remember. But within this data information, all the fields that we captured are available to us here when we expand this out as table format, or we can look at the raw JSON that the Elasticsearch system captures for this data element. And the great thing about this is that I can actually use just the specific fields I might be interested in. So I want to know, what was the building claim? How much was that for? What about the contents claim? So personal property, what was inside of the building during the loss? What was the actual date of the loss, right? Then let's look at things like, was it a house of worship? No. Were they primary residences? What city and what state are we looking at here? And then let's say we want to look at what was the delta between insurance coverages for both the building as well as the actual amount paid on claim. So we can look at the data this way, and we can use this to really filter in and hone in on the information and data that we're looking at. So as I zoom in on specific portions of the state histogram, notice that all the information that's being updated in real time for me. So my data table is updated in real time, the number of hits, so the aggregation, it's all being performed that fast. We're not pre-summarizing any of this. We don't use summary tables or anything like that at Elasticsearch. This is all because we built this on a search index on the back end where all of our fields of values, a lot of the statistics that are available to me and the system are pre-calculated and taken advantage of to help you understand and look at your data. So that's just one way for me to introspect and do analysis, perform some preliminary discovery about my data here. But usually after that, the next phase is I need to create some visualizations. What can I do here? So we're going to take a look at some of the ones I generated for today's sort of dashboard. So let's look at this one here. So this one here, I'm going to change the date. We're going to expand this out to be a total. Is just a visualization that allows me to provide a filter. So these filters are values, right? So these are specifically text fields that have been parsed as keywords that allows me to use them as a select box or values that I want to filter down on within my particular dashboard that I'm going to leverage. So if I say Louisiana, the great thing is it's going to actually filter down my reported cities as well. But if you recall, my actual data set itself, everything was just written out flat. Every incident, every claim had the state, the reported city. But being able to filter this quickly is because Elasticsearch takes advantage of modern scale-out technology, and we're able to store all these data structures in memory to help make it as fast as possible. So let me back out of this one. Let's look at, here's another one. Well, you might not think of this as a neat visualization, but we're also able to look at tag cloud. So essentially what I've done here is I've just applied a tag cloud visualization on the state value column to understand, all right, across my document set, in this case, we're isolating to a specific date period, who's got a lot of claims. In this case, we see Louisiana as being sort of the most visible one in this tag cloud, but we see other states too being pretty relevant. We got Georgia, we got Florida, right? And typically these are very coastal states as well. So that makes sense, right? We're talking about flooding, things like that. So that would make a lot of sense. I would come out of this, but I do want to take this and show you what's the next level of this. What do we do with these visualizations? And the next part of that is to pop those into what we call a dashboard. So here what you'll see is a dashboard that I generated based off of those individual visualization components. It's not the cleanest thing. I do admit that I am not the best artistic designer in the world, but it is functional at least, right? So every one of those control visualizations that we showed you before, so there's state and the reported cities available here. In fact, we even have a slider control bar for the year I lost. So let's say I want to take this from, I don't really care about what was, 3 decades ago. Let's look at stuff that's more recent. Let's isolate this to the 2000s, right? Or let's go, right? We'll do 99 in case there's something else interesting up until, let's say, 2010. That's all I'm concerned with. This is important. If you think about business analytics and business reporting, you want to know where's the funding going? Who's taking all the money, right? That way, do you need to beef up FEMA's funding, right? How do you do that? Well, you need data to help drive that information and decision. And floods are just one thing that FEMA deals with. In today's climate, right, in the last several weeks and months, FEMA's dealing with a different set of problems. So how do we know that they need the budgets that they're asking for when it comes down to budget cycles with Congress? So if I apply those changes, here's what's great about this. Every single one of the visualizations updates with that information and filters it down. So we're calculating that with every single update or change of the filters that are available here. So lo and behold, for an end user who's not an Elastic expert, we're not using these filters we're just using these controls as a way to allow them to filter these controls. So if you think about how you shop online, isn't it great if you just have a little control to drag and drop versus having to type out, I want to know where my year of loss, right? Who searches and shops for things like that? Nobody. So we want to bring that experience to a wider group of people to allow them to do analytics beyond just the experts. And this is what the dashboard capabilities will do for those. Here we have a heat map. And what's really cool here is we've got this map embedded as part of our capabilities as well. So what the maps are, actually, let me expand the sidebar here. We have a map app. So the Maps app allows us to apply a visual representation of the location of documents that we're storing inside of Elasticsearch. You can layer this with a number of different maps, and you can use your own tile map service as you need to as well. But in our case, we're using the standard one that's available by Elastic. And what's great about this is that all this information is stored in Elasticsearch. And as long as I have map data, geopoint locations, right? So lat, lon information, I can use the map tools to allow me to filter the data even more. So we saw that, hey, I used a slider here to update and give me the information that I need just for 99 to 2010. So all the stuff got updated for me so I can help drive my report. But now I can do this. I can draw a shape on my map and isolate it to, I just want to know this location. Now, who knows the different coordinates of a particular polygon that you want to do a search query for? I certainly don't. But as I come in and draw this here, everything's updating for me. So I can isolate and localize my results just to this particular boundary. Let's go into Houston too. And you'll see that all the figures are changing. Clearly, there's a hotbed of activity here in Louisiana and into Texas, but I'll let you all determine what that was. It was in 2005, August. That's why we see a large number of claims for both building and personal property through this. Now, not a very intriguing analytic, but the point here is that it's very easy to give these sort of analytic tools to end users that aren't necessarily experts at data analytics or data analytics SQL queries. We're using the data itself to help drive their analysis. If I really wanted to, I can just search for something here. Let's say I'm interested in understanding, which ones were in Louisiana. I don't even want to use the selection tool. I just want to do a query. We can do that here in this field here. Oops, something. So another cool tip here is that it allows me to give me type aheads. If I say, hey, I want to look in the state field, it gives me some of the top values that are available to me in this environment. And it does that state, Louisiana. There you go. There you go. Refreshes right on time. Perfect. Here's just a heat map of some of the coverage, the how much they were covered, and just buckets them into amount ranges for us here. And then down here is my data table. So this data table provides me all the different claims that represent this amount here in this particular bubble here. As I zoom in, the map gets more granular. I get higher fidelity of the information of the location. And again, if I actually had the geo coordinates of each individual claim, I'll be able to see each property individually on this map. So there's a couple of features here that are available for you all to take advantage of as you do your analytics. In this case, I can actually also share. I think one of the things that we mentioned was, how do I get this and share this, right? If I have an analysis available to me. We have a number of ways to do online sharing with embed codes and links that are available, but I can actually generate this as a PDF, send that out to management as I need to, or even a PNG as I need to for my dashboard. Oh, by the way, this was data that I got from FEMA. So OpenData, I was actually looking for fire data, but I came up with flood data, and this was a pretty decent data set to work with. It was kind of fun. If you don't want to get some data, source it, and do some basic cleaning of it, Kibana actually, whoop, zoom back out. Kibana actually includes a few data sets that you can add automatically. So if you just go and log in, there's an add sample data. You can go ahead and install some of the samples that we have if you want to just start exploring. And these samples come pre-configured with some dashboards and visualizations you can play with. And again, the easiest way to get started and just to play around is to sign up for our cloud trial. Again, the AWS GovCloud beta is available today, 14 days. So I encourage you to sign up and just get started playing around with this information and data. At this point, I'll take it, hand it back off to Faith and close out the session.
Awesome. Thanks so much, Richard. Folks, if there are any questions, please send them through in the chat or in the Q&A. If not, then we'll just end here.
Yeah, this session is recorded, so if you need to pass this around to friends, colleagues, etc., feel free to.
Awesome. Well, we will be sending out the recording, and again, I encourage you to join our NASA virtual group so that you can stay up to date on the latest virtual meetups at Elastic. Thanks everybody for your time.
Oh, hold on one second. We got one question. So the dashboard that I showed today in my demonstration, in all transparency, they were created by me for a specific user, a specific customer I was showing some of the capabilities for. So this was made by me for that particular customer. If you want to explore and play with your own dashboard, you can go ahead and in the same instance that you have set up as your evaluation and your test bed, there's an add sample data. So when you click there and you add any one of these, the web logs, the flight data, or the e-commerce orders, you can click on some of the pre-made sample dashboards involving the data that gets loaded. So here, if I had installed sample flight data, I can view that dashboard out of the box without having to create any of this myself. One pro tip about Elastic that trips everybody up is they come to a dashboard and they're like, oh my gosh, there's no data. This product sucks. Sorry, I probably shouldn't have said that. This product's not doing what I expect. Well, here's the pro tip. Oftentimes, it's because the time picker is not for the time span that you're looking for. So one way to do this is just go, hey, let me just look at the last year. And then you'll start to see your results appear. And then if you need to refine that, you can get closer to the time frame that you need. But again, remember, we've got interactive visualizations where I can just drag and drop and update all that for me. So that's just a pro tip for y'all to understand that, hey, if you're missing data, just click the time picker and you'll probably figure it out. Okay, next question here. The geo-coordinate feature can be easily added. Yes. So within Kibana and being able to leverage it is nothing special. As long as it's tagged as part of the data set incoming, you can just start using it. The trick there is being able to get the data and associate that and enrich it. And there are a few ways to do that. Oftentimes, it'll include Logstash to enrich that particular document as it's flowing into Elasticsearch. And you'll have some other source system that helps you determine and provide that business logic and get you those geo coordinates. But once you've done that, working with it inside of Kibana is just there, just available. You said that you have an offering for Kubernetes on GCP. If I already have a cluster, would you integrate into my current clusters, or would there be another cluster that I would interface with? If it is the latter, would it be better to just use Elastic Cloud and have my services on the Kubernetes cluster point to that service? I think this question is going to be a lot of depends on how you operate things today. Assume that you meant cluster by Kubernetes cluster. So you have an existing Kubernetes environment that's shared across many different apps and teams. The way that the ECK operator is developed is for you to take advantage of that common infrastructure, that shared common infrastructure. And the ECK will put Elasticsearch on the appropriate pods as it needs to, so that way you have both the fault tolerance and the high availability, and knowing what resource limits to give it and things like that. As far as moving to Elastic Cloud, I'm a big fan of that. So that way, it takes a lot of the carrying and feeding that you might be doing today with Elasticsearch off of your hands. So just going through an upgrade. Elastic Cloud lets you do it with zero downtime by clicking a button and selecting the version that you want. I know today a lot of my customers that are on-premises self-managed deal with upgrade cycles maybe once a quarter, maybe once a year, because there's a lot of pre-planning, there's a lot of execution, there's a lot of testing. Elastic Cloud has all that workflow pre-baked in, so that way there's an assurance that your upgrade will go smoothly. And if it doesn't, you still get the same tech support that Elastic support engineers provide to help you get up and running and operational again as quickly as possible. So in a nutshell, the answer is it depends, but I'm a huge fan of using the Elastic Cloud service, especially now that we have the GovCloud region available as a beta. I think that's it for the questions. Hopefully that was helpful for everyone.
Definitely. Thanks, everybody. And again, we'll send out the recording as well as some links to our virtual user group.